Alright, so in this video we'll be talking about and discussing about the basic integration formulas. No, but first we need to have to define the concept of an integral, the process of integration. So we have here the mathematical representation of an integral. So for example, if we are going to get the integral of f of x or a function of x in terms of dx, so the answer for that one is the original function of x plus the constant of integration. So this type of integration is what we call as an indefinite integration. Okay, so the purpose of having this indefinite integration is for us to integrate our integral without mining for the limits, and also to have a general solution of our integral. And the limit itself, the concept limit itself, is being added to the answer by this notation here, the c, which is the constant of integration. Okay, so suppose if we are going to take the okay going to take the derivative no of f of x, so this will be equal to the f of x dx, right? No, so that is the derivative of this function is equals to the function times its derivative. So if we are going to integrate both sides of this equation, okay, so we will have this one, no? So, and we know that from the given definition, so this part here could be also equal to f of x plus c. So therefore, the derivative of f of x, the integral derivative of f of x is equals to f of x plus c, which is the main definition of an integral. So to get the actual function which is being derived, which is and which we are going to get the derivative, so we use the inverse of differentiation, which is integration, to get the original function itself. And because it is indefinite, so we will have a constant of integration. Okay, now what if we are going to differentiate both sides? Okay, so for example, we have there the integral d of x is equals to f of x then plus c. So we're going to take the derivative of both sides, okay, so we'll end up with, so the derivative of f of d of x, okay, we have here d or derivative of f of x is equal to, so the derivative of that one is, okay, so this will be 0, and also this one, so the, okay, from our previous slide, so this notation here, the derivative here is just equal to this one. So this is just equal to f of x dx. So what does it mean? So if we are going to take the derivative of an integral, our answer will be the derivative of the function of f of x, or the derivative of the original function. So these two prove that integral, therefore integration is the inverse operation of differentiation. Okay, yeah, so we will put the exclamation point. Okay, so let's use this principle, no, in some examples. Okay, we have here, so the derivative of the integral of 3x squared. So for this one, so our f of x is equals to 3x squared. So by definition, okay, so is equal to f of x dx with this one. So our f of x is 3x squared, no? So the derivative of the integral of 3x squared dx, no, is just equal to 3x squared dx, no? And that is our answer for number 2. So same. So our f of x here is equals to sine x. So the derivative of the integral of d of x is equal to sine x dx. So there, not sine x dx, but f of x, sorry. Okay. So this is equal to f of x dx. So the derivative, the integral of sine x dx is just equal to sine x dx. Okay, so now we will go to the formulas, no, the basic integration formulas. Now, 5 basic integration of formulas. First, we have this one. So the derivative of the integral of the derivative of u is equals to u plus c. No? So this is indefinite, so that's why we have c here. So all of our discussion first will be about indefinite. So we'll have all plus c, no, after our final answer. Then we have the linearity or distributive property. So the integral of u plus v dx is equals to the integral of u dx plus the integral of v dx. Then the integral of eu dx is equals to a integral of u dx, in which your a is a constant. Then this is the power formula. So the integral of u to the n, wherein your n is the exponent, is equal to u to the n plus 1 over n plus 1 plus c. The last one is the ln, or the natural log. So the integral of du over u, wherein your u here, the exponent is 0, is equals to, oh no, that's what is 0, the exponent is 1, no, is equals to ln u plus c. Okay, so to apply this formula, we will have some examples. So our first example for the formulas, we have here the integral of 6x squared minus 4x plus 5 dx. Okay, solution. So we have the integral of 6x squared minus 4x plus 5 dx. So the very first thing to do is to distribute, no? So use the linearity theorem. So 4x dx plus 5 dx. And after that one, we need to separate the constant, no, from the given integral expression. So we have x squared dx minus 4x dx plus 5 dx. So for this one, this is an exponent, so n is equals to 2. This one is n equals to 1, and this one has no exponent. So here we will use the power formula. So we have 6 x2 plus 1 over 2 plus 1 minus 4 x1 plus 1 over 1 plus, no, what, this 1 plus 1, not x plus 1. Okay, this will be 1 plus 1 plus 5. So the derivative of dx is x, so you could now put c on there. So we have 6, so this will be x cubed over 3, so 2 plus 1 is 3, minus 4x squared over 2 plus 5x plus c. Okay, So cancel. So this will be 2. Cancel. This will be still 2. So we have 2x cubed minus 2x squared plus 5x plus c. Okay. So this will now be our answer. Okay. Next, another example. We have here the integral of 4 cube root of x minus 2x square root of x dx. Okay. Solution. So we have the integral of 4 cube root of x minus 2x square root of x dx. So we first use the linearity theorem. So we have 4 cube root of x dx minus 2x square root of x, no? Integrate that one in terms of x. Okay, so to make our expression much simpler, so we need to transform, no, our radical into an exponential form, no? So we have 4, so cube root, that is x raised to the power of 1/3 dx minus 2x, so that is square root, that is x raised to the power of 1/2 dx. Now we just separate our constant. Okay, so minus, so we'll add, no, so this is 1 plus 1/2, so we have x raised to the power of 3/2. Okay, so we need to separate our constant. Okay, dx. Okay, so now this is n is equals to 1/3 and this is n is equals to 3/2. Okay, so you have 4x to the 1/3 plus 1 over 1/3 plus 1, then minus 2. So we have minus 2x 3 over 2 plus 1 over 3 over 2 plus 1 plus 1 plus c, no? So this will be, write this one so that it will be much clearer that this is 1/3. 1/3. Okay, so we have 4, so 1/3 plus 1, that is x raised to the power of 4 over 3 over 4 over 3, same, minus 2, so you have x raised to the power of 5/2, so 3/2 plus 1 over 5/2 plus c, no? Okay, so we just continue over here. So we have, so half and square going to cancel, no, our 4, so we're left with 3, no, using the reciprocal rule. So we have x, 3x is the power of 4 over 3, so our 5 will be the numerator reciprocal rule, so this will be 4, so minus 4 x 5/2, so this is all over, or we just put 5 here, plus c, no? So this will be our answer. Okay, so now let's proceed to another example. Okay, so we have this one, the integral of 1 plus cube root, no, of x squared, so divided by the cube root of x squared, x pala, no, not x squared but x dx. Okay, so solution. Okay, so integral of 1 plus so this is 1 plus cube root of x squared over cube root of x dx. So the very first thing to do is to expand that one of this given expression. So 1 plus cube root of x multiplied by 1 cube root of x. So we have cube root of x squared. So cube root of x. So we have also 1 third cube. This is also cube root of x plus 1. So we have 1 plus 2 cube root of x plus cube root of x squared. Okay, so we substitute the expansion in this expression. So we have 1 plus 2 cube root of x plus cube root of x. So they are all squared, all over cube root of x dx. Okay, so now let's use the distributive property or the linearity. So we have 1 over cube root of x plus 2 cube root of x over cube root of x minus cube root of x squared. No? So we have here dx. So I forgot to put the dx. So dx is still dx all over cube root of x. Okay, so what will happen is we're going to simplify this one. So this will be cancelled out. So this will be deducted by 1. This will be cancelled out. So we're left with the integral of 1 over cube root of x dx plus the integral of 2 dx minus, this is minus or plus? No, plus. Okay, plus the integral of cube root of x dx. Okay, so we will use another sheet for this one. Okay, okay, so let's proceed to another slide now. Okay, so what we are left with, we have this one will be equal to the integral of, so we just transform our radical into exponential form. So this is 1/3 to dx and 1/3. Okay, so we will have the integral of dx over x raised to the power of 1/3. So is it plus or minus for the next term? So that will be plus. Okay, so this will be plus 2 dx. This will be plus also the integral of x raised to the power of 1/3 dx. So we will be erasing this also, no? So it will become negative 1/3 dx. So just have the constant outside. Okay, okay, so this one, the n for this one is negative 1/3, for this one is positive 1/3, no? So we'll have x negative 1/3 plus 1 all over negative 1/3 plus 1 plus, so the derivative of this one, the integral for this one is 2x plus x to the power of 1/3 plus 1 over 1/3 plus 1. So we could put plus c there. So this will be equal to negative 1/3 plus 1, so that will be x to the power of 2/3. So this is also 2/3 here, plus 2x plus x 4 over 3, or 4/3 over 4/3 plus c. So using the reciprocal rule, so we will have 3x 2 to the power of 3, or 2/3 over 2, plus 2x plus x raised to the power of 4/3. So this is over 4, and we have 3 here, plus c. And that will be our final answer. Okay, so we'll have another example. Okay, so we have this one, solution for this one. So we have 2x minus 1, 3x plus 4 dx. So we need to first expand this one. So 2x minus 1, 3x plus 4. So this will be negative 4. So this will be positive 8x. So 3x times negative 1, so negative 3x. So that will be 6x squared. Okay, so we have negative 4. So 3 minus 8 minus 3, so that will be 5x. So 6x squared, positive. Okay, so we just put that one here, 6x squared plus 5x plus 4 dx. Okay, then what we are going to do now is to distribute 6x squared dx plus 5x dx plus 4 dx. Then we just put the constant outside. Okay, so 5x dx plus 4 dx. So this will be n is equals to 2, n is equals to 1. So we have 6. Okay, so for this one, so our 4 is negative. So sorry for that one. So we need to erase this one here. Okay. Okay, so our 4 is negative. So sometimes we need to be careful with the sign of our terms. Okay, so this will be x 2 plus 1 over 2 plus 1 plus 5 x 1 plus 1 over 1 plus 1 minus 4x plus c. So we'll end up with 6x squared over 3. So this is not squared but 3, x cubed plus, so this will be 5x squared over 2. Okay, then minus 4x plus c. So this will be cancelled. So this will be 2. So our final answer will be 2x cubed plus 5x squared over 2 minus 4x plus c. Okay, so this will be our answer. Okay, so our last example. So we have here solution. Okay, so we have the integral of the square root of x to the 4 minus 2x cubed plus x squared. So this will be dx. So the very first thing to do is to factor out, factor out this one. So the common is x squared. So we end up with x squared minus 2x plus 1. So also you could factor out this one. So we have, so this will be x squared times x minus 1 squared. Okay, so I could separate the radical. So we end up with x squared times x, the square root of x minus 1 squared dx. So this will be equal to x times x minus 1 dx. Of course, we could have the x here plus and minus plus and minus, but for simplicity of the solution, so we just have here the positive, no, the positive of x, no, this one, this the square root of this one, the positive root, and the positive root for this one. Okay, so distribute that one, so we have x squared minus x dx. So we have x squared dx minus x dx. So let's continue over here. So this is n is equals to 2 and n is equals to 1. So we'll end up with x 2 plus 1 over 2 plus 1 minus x 1 plus 1 over 1 plus 1 plus c. So we have x cubed over 3 minus x squared over 2 plus c. So this will be our final answer. Okay, so that will be the end of this video. I hope you learned something from this, and as always, enjoy learning.